Hi, this is Juan from JuanTutors.com. We're working on the August 2016 New York Geometry Common Core Regents problem number 1. If you want to access these exams, go to nysedregents.org. They're freely available there. So here's the problem. In the diagram below, lines L, M, N, and P intersect line R, and I see, okay, line M, L, M, N, P, and line R. Which statement is true? L parallel to N, L parallel to P, M parallel to P, and M parallel to N. So I recommend that you pause the video, try the problem on your own, see if you get the right answer, and if you do, definitely hit the like button so that we can know that you got it right. Which statement is true? Let's see. So I always like to give a process of elimination type answer, and this is the hint that I'm going to give you. It's a points type hint. It's not the best hint that teachers would recommend because it's not based on theory. It's based more on the way the tests are constructed. They give almost every diagram drawn to scale. They're not required to give a diagram to you drawn to scale. And in fact, they don't have to even label it as not drawn to scale. However, in my years now of over a decade of grading geometry regents, I've actually only seen one diagram really truly not drawn to scale that wasn't actually labeled as not drawn to scale. So if we make the assumption that this diagram is drawn to scale, if we have no clue how to do it, and we make the assumption that this diagram is drawn to scale, well, line L and line N look like they intersect somewhere below line R, so they're probably not parallel. Line L and line P look to be pretty parallel, so I would bet that that's going to be my answer. Line M and line P intersect somewhere below R, and line M and line N definitely intersect below R, somewhere right around this point over here below the letter I. So that's my guess is going to be number 2, even without using theory, just because of the fact that they seem to not intersect. Now let's go through the answer and use actual theory. So first off, they say line L and line P. And I'm going to try to get the answer that that I think is correct. Good strategy. I see line L and line R make this angle of 112 degrees, and then line L and line P make this angle, which is 68 degrees. Now, what do I notice? If given line L and line P, line R would be a transversal because it passes through both lines at 2 different points. These are both above line R, so they're on the same side of the transversal, and they're outside line L and line P, so they're exterior angles. They're same side exterior angles, and there's a theorem. Line L is parallel to line P if and only if same side exterior angles are supplementary. And in this case, we have a 112 degree angle plus a 68 degree angle is equal to, well, 112 plus 68, we can definitely use our calculator. 112 plus 68. I recommend if you can't do that arithmetic, you use a calculator. And if it's quick, check your answer on the calculator, but you should be able to do this in your head, that 112 plus 68 is 180. So, in fact, those two angles are supplementary. Those two angles are supplementary. As we expected, so line L is in fact parallel to line P. If you didn't believe it, or if you tried testing another set of angles first, then we can go. Let's say we were trying to compare line L and line M. Okay, I'm sorry, line L and line N. So I'm gonna mark this angle with a black angle, with a black arc. 3 of them, and then that angle compared to the angle at line L. So I'm testing this one. I'm testing choice 1. Those two are on the alternate sides of the transversal. One's above, one's below, and they're exterior to line L and line M. Alternate exterior angles should be congruent. but 112 is not equal to 122, so these angles are not congruent, and so line L is not parallel to line M. Line M and line P, let's see, this angle here marked in a blue arc and the angle at line P, those are alternate sides of the transversal, and they're exterior to line M and P and line P. So they're alternate exterior angles. If the lines are parallel if and only if those two angles are congruent, but they're not congruent. So we know that these are in fact not parallel. And line M is parallel to line N. These are the same side of the transversal. This blue angle, this black angle, and they're exterior to line M and line N. They should be supplementary, but 122 plus 78 is equal to 200, not equal to 180. So those two angles are not supplementary. So these angles are in fact, these lines are in fact not parallel. So that's how to do the question. We went through in the positive sense, determining that line L and line P were parallel, and we also eliminated the other answers as a check, which I highly recommend that you do. You have plenty of time on this test, so definitely check your answers. So here's the problem created by us. By the way, if you noticed a weird cut up between the first half of the video and the second half, it's because the wording of the problem that we created was actually off. So we actually had to do the second half of the video in a separate part. So here's the problem. In the diagram below, angle ABD is congruent to angle CDB, and we see that angle angle ABD and angle CDB are congruent, which statement could be false. Now, the advice that I give you, pause the video, try it on your own. See if you get the same answer as us, and if you do, definitely hit the like button to let us know, and feel free to subscribe as well. You know, we're here to help you, and hopefully you'll find these videos useful. So this is the advice that I give to every student. Remember that your goal is to get the highest grade possible. So definitely, if you have no clue how to do this, at least try to assess which answer looks to be correct out of these four. Chances are that one of these answers will be glaringly wrong. Let's go over it now. Let's see what we know. Angle ABD is congruent to angle CDB. So these two angles share this line EBDJ, and that makes LABF and line KDCG parallel, because these two angles are alternate interior angles. So alternate interior angles, let's write the full words, alternate interior angles are congruent, and that's if and only if the lines are parallel. Okay, parallel. So as a result, LABF is parallel to KDCG. Those two lines they're parallel, and all statements that are true about parallel lines with transversals going through them are, as a result, true. Alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, same side interior angles are supplementary, same side exterior angles are supplementary. So let's see if we can determine based on these statements which is definitely true, or which could be false. So angle BAD, let's label these in blue for number one. So angle BAD, that's this angle in blue, is congruent to angle CDI. Okay, so these two lines are parallel, and this would be a transversal for those two lines because it crosses both lines at a unique point, and that makes these two angles corresponding angles, which means they're congruent. So corresponding angles are congruent. Corresponding angles because they're on the same side of the transversal. One is interior, one is exterior, and so this is definitely true. Okay. Let's see. Let's do the next one in red. Angle EBF is congruent to angle JDK. Angle EBF is up here in red, and angle JDK is down here in red. So these, again, this would be the transversal for these two angles, and then they also have these two lines being used to make the angles. The lines are already, we know, to be parallel. These are on alternate sides of the transversal, and they're exterior to the lines. So these are alternate exterior angles. Alternate exterior angles are congruent. So these are definitely congruent, so this must be true. The next statement, LABF is congruent to KDCG. We said that over here. So that is definitely a true statement. That's just straight due to the fact that these two angles are congruent, alternate interior angles are congruent. So as a result, this has to be the answer. This is the only thing that's left. So now let's see if we could determine why that one could be false. LABF is perpendicular to MADI. First off, they don't look like they're perpendicular at all. Second, the two lines that are said to be parallel, they definitely look parallel. So there's no way for these two lines to necessarily be perpendicular. Now, why don't they have to be perpendicular at all? Why could, in fact, they share any angle correspondence? Because there is no restriction on the existence of line MADI. There's no restriction on point A at all made by the existence of the two parallel lines. So at point D is part of the diagram as described before, but point A could be moved downward or upward freely. So the angle between MADI and line LABF could vary just as freely. So that answer could be false. So that's it. Hopefully you got it. Listen, you can do it. Just keep working at it. It takes a little bit of work. Keep watching these videos, and definitely stay tuned for the next video starting right now.